about limits. A limit of a function, f of x, as x approaches some value c, is equal to the y value that f of x approaches from the left and the right side. In this example, the limit as x approaches c is simply f of c because this function is continuous. In other words, at x equals c, f of x is not continuous. If the value approached from one side is not equal to the value approached from the other side, then the limit is said to not exist at that value of c. For example, when we look at g of x, the limit as x approaches d from the left side is this value, while the limit as x approaches d from the right side is this value. Since they're not the same y value, then the limit at x equals d does not exist for g of x. There are two types of discontinuities, removable and non-removable. You can think about continuity as if you can draw a function line without lifting your pen. The function is continuous. A removable discontinuity is a hole. For example, when we look at h of x, we see that this function does not have a value at h of e. However, it does have a limit because it's a hole. The same value as h approaches e, as x approaches e for h of x, the same value is of h of e, from the right side and the left side. A removable discontinuity is a hole where only that value of x does not have a y value, but there's a limit of f of x as x approaches that value. A non-removable discontinuity would be like when the value approached from one side is not equal to the value approached from the other side, then the limit is said to not exist at that value of c. Another type of discontinuities are asymptotes, but those are also limits. When we look at h of x, as x approaches infinity, we see that h of x gets closer and closer to the value of m. So m is known to be the limit as x approaches infinity of h of x. Our first practice problem is the following. Find the limit as x approaches 0 of sine x over x. When we simply plug in 0 for x, we get that sine 0 over 0. However, sine 0 is 0, so this is a 0 over 0 form, which is an indeterminate form. So in order to find this limit, we need to use L'Hopital's rule. So L'Hopital's rule basically states that as the limit as x approaches some value, c, in this case it's 0, the function f of x, in our case which is sine x over x, is equal to the limit as x approaches that same x value of the derivative of the numerator divided by the derivative of the denominator. So the derivative of sine x we know is cosine x, so the numerator would be cosine x, and the derivative of x is simply 1. So now we simply plug in x, 0 for x, and we get cosine of 0 over 1, and cosine of 0 we know from our unit circle is 1, so 1 over 1. So the answer would simply be 1 for this problem. Our next problem is, find the limit as x approaches 3 of 3x squared minus 4 divided by x plus 1. Pause here now if you want to try this problem out for yourself and then come back to see the answer. Okay, so now we're just going to plug in 3 for x and see if it gives us an indeterminate form or not, and if it does, then we're going to use L'Hopital's rule. So 3 times 3 squared minus 4 divided by 3 plus 1, which is 3 squared is 9, 9 times 3 is 27, so 27 minus 4 divided by 4, which is 23 over 4, which is our answer. Our next practice problem is, find the limit as x approaches 2 of 5x minus 10 divided by x squared minus 4. In this problem, we're going to use a handy trick, which is called factoring. And if you want to try to do this problem by yourself, pause here to try out and then come back to see the answer. So right off the bat, we notice that both the denominator and the numerator are divisible by x minus 2. So we can rewrite it like this. So we can just cancel out these two values because we know that the same value for any x value, x minus 2 will have the same value for both the numerator and denominator, so it can be divided out. So we'll just be left with 5 over x plus 4. This will eliminate the problem of this function not existing at x equals 2, since now we don't have to worry about that. So our answer will simply be 5 over 2 plus 4, which is equal to 5 over x, 6. So now you may be wondering that this function does not exist at x equals 2, so how can we just find an answer for a discontinuity, right? But the thing is, the limit is not the same thing as an x value, as a y value. It is just the y value that it approaches. So this is in fact the correct answer. So this is our next problem, and it's also the last problem. So we're given a graph of y equals f of x, and we need to find all of these values. So the limit as x approaches 4. So 4 is right here. Now we see that from the right side, the value of f of 4 is somewhere around negative 2.6. And also from the left side, it approaches negative 1.6. So the value will just be negative 1.6. The limit as x approaches negative 1 will be 4, because from the right side it approaches 4, and from the left side it also approaches 4. So the answer is 4. The limit as x approaches 3 is an asymptote. We can see that it's an asymptote right here, but since it approaches negative infinity from both sides, the limit is negative infinity, even though it's an asymptote. The limit as x approaches 2 of f of x. So from both, even though it does not exist at x equals 2, the limit does exist. The limit is 1, because from both the left and the right side, it approaches the value of 1. So f of negative 1 would just be 4. This is a pretty straightforward answer. Limit as x approaches 5 is, since the value limit as x approaches 5 is different from both the right and the left side, this does not exist. So we can just say DNE, which is basically the abbreviated form of does not exist. So limit as x approaches 5 from the right side. So the plus sign after the 5 basically signifies that it wants the limit as x approaches 5 from the right side. So as x approaches 5 from the right side, right here, we notice that it approaches this value 2. So the answer will be 2. The limit as x approaches from the left side, which is signified by the negative sign, is this value, which is negative 1. So the answer will be negative 1. And here are your answers.